Hi everyone. Today we'll discuss Gauss-divergence theorem. We'll discuss Gauss-divergence theorem. What is Gauss-divergence theorem? Integral del dot f dv equal to integral taken over the surface f dot n ds. So that means volume integral equal to surface integral. That what is volume integral? Triple integral. What is surface integral? Double integral. Volume double and triple integral, if you are combining saying equal, we are saying with the help of the Gauss divergence theorem. So to verify Gauss divergence theorem for the function f equal to 4xy of I minus y square j plus zs of k over the cube bounded by x equal to 0 to 1, y equal to 0 to 1, z equal to 0 to 1. So we'll prove the theorem. So now first, so we will go del cross f. What is our del? I dou by dou x, j dou by dou y plus k dou by dou z. Taking dot product of f. What is f? 4 x y of I minus y square of j plus zx of k or zx of k. Now going with I, dot product I dot I is 1. So dou by dou x of 4xy plus dou by dou y of minus y square plus dou by dou z of zx. So if you differentiate with respect to x, it is 4y minus 2y x. 4y minus 2y is 2y plus x is our divergent f. That's it. Now divergent f is, we got divergent. What we have to find? Integral taken over the value v del dot f dv. What is del dot f? Volume integral is triple integral. What is del dot f? 2y plus x. What is dv? dx, dy, dz. You see, we volume integral, 3 integral over x, over y, over z. Now, and he has given the boundaries. In the problem it is given x equal to, you see here, the problem it is given. What it is given? You see, 3 boundaries he has given. X equal to 0 to 1, y equal to 0 to 1, z equal to 0. So that's we are using that. X equal to 0 to 1, y equal to 0 to 1, z equal to 0 to 1. X equal to 0 to 1, y equal to 0 to, all are 0 to 1, so we don't have to see the order. So now separating the integral. 0, 0, 1, 1, 1. 2y is there, dx, dy, dz. Plus 0, 0, 1, 1, 1, 1, x, dx, dy, dz. Now this is 0 to 1 to y dy, 0 to 1 dx, 0 to 1 dz, plus 0 to 1 x dx, 0 to 1 dy, 0 to 1 dz, 0 to 1 dz. So this will be y square by 2, 0 to 1. This derivative of dx is x, 0 to 1, 0 to 1. Derivative of x is x square by 2, 0 to 1. Y is dy, dz is 0 to 1. So this is 2 getting cancelled. Y square is 1. 1 square minus 0. 1 minus 0. This is also 1 minus 0. This is also 1 minus 0. This is 1 by 2 taken common, 1 minus 0. 1 square minus 0. 1 minus 0. 1 minus 0. So this is 1 minus 0. 1 minus 0 is 1. plus 1 by 2. So 1. So 1 plus 1 by 2 is 3 by 2. So 3 by 2 we have to keep in our mind, that is divergent f dv is 3 by 2. This is first part. Now we have to go for the six phases of the six phases. Cube heat is given. See in the problem. The cube over x equal to 0 to 1, y equal to 0 to 1, z equal to 0 to 1. So draw the cube. Let me draw the cube. Suppose this is suppose this is your x-axis, this is your y-axis, this is your z-axis. So this name it A, Q, P, S. A, B, C, and this is our PQRS. PQRS. This is the thing. Now we have to go for the six phases. For the six phases. Phase 1. For the phase AQRS. For the phase AQ AQPS. We'll take PS, not RS. AQPS. AQPS. This is the phase. For the phase for the phase AQPS, you see x is starting from 0 to 1. For the phase x equal to 1. X equal to 1. And unit vector n equal to I we will take. And y is running from, you see, x is 1, y is from 0 to 1, and z is 0 to 1. And our ds is dy dz. And and dy dz. So integral taken over the surface S1 f dot n ds. F dot n ds. What is our f? What is our f? Our f is 4x y of I minus y square of j plus zx of k. Now, dot n is I. What is our ds? ds is dy dz. So now this is I dot is 1. So our surface integral will be 4xy dy dz. And it is 0 to 1. And see here, if you substitute here, derivative x is 1. So x is 1 if you put y dA. So 4 outside, 0 to 1, y dy, 0 to 1 dz. So this is 4, y is y square by 2, 0 to 1, z is 0 to 1. So here y square is 1, 1 minus 0 is 1, 4 1 are 4 2 are. This is 1 minus 0, it is 2. This is 2. Now Now for the second phase, for the phase, for the phase OBRC, OBRC. See here, this is the phase opposite to this phase. Opposite to it, for the phase opposite to it, x equal to 0, x equal to 0, and n equal to I is there, so it will be n equal to minus I. And same, y equal to, y will be 0 to 1, and x will be, z will be 0 to 1. And ds is dy dz. Now surface integral, you see surface integral, taking surface integral f dot n ds equal to, you see if you go with this I means 4x, you see this one is there, double integral, it will be same, double integral, it will be double integral, and n equal to minus I this will be minus 4 xy dy dz. And what is that? X equal to 0. If you put x equal to 0, so this value becomes 0. Okay, next. So name it number 2. Number 2. Now for the phase 3. For the phase, BQ, PR. See here, sir. See here, don't get confused. It's very simple. BQPR. You see BQPR. This is the phase. This phase. BQPR. This phase. Then we'll go for this phase. Opposite to this. BQPR. So this means BQPR means here you see. BQPR. BQ B B for the pay for the phase OB OB 1 minute. 1 minute. This is first phase. The second phase. Now for the third phase, let me go with the third phase. For the third phase, BQPR, BQPR. So n equal to, for the phase BQPR, n equal to j and y equal to 1. Now the variable is x equal to 0 to 1, z equal to 0 to 1, 0 to 1. So what is our the surface? Surface S S3 f dot n ds. F dot n ds is double integral 0 to 1. And what is that function? Our function is, let me write on the function. Our function is 4xy of I minus y square of j plus zx of k dot n. Our n is j. Power of ds is dx dz. So now this is j is there, this is j dead. So minus y square. Minus y square is there. Minus, so 0 to 1, 0 to 1. So minus y square dx dz. What is y square? What is y? Y is 1. Y square is 1. So therefore it is minus 0 to 1 dx, 0 to 1 dz. So this will be x 0 to 1, z 0 to 1, minus with minus sign. With minus sign. So this will be 1 minus 0, 1 minus 0. This is minus 1. Name it 3. No, S4. S4 we have to go for S4. F dot n ds. So it is 0 to 1, 0 to 1. And you see, for that phase, what we are getting here? See what we are getting here? Here, minus y square dx dz. And what are the other things? Y equal to 0, n equal to minus I. ds will become dx dz. Minus I means this will be become, and y equal to 0. If we put 0, everything becomes 0. This is 4. One more phase. One more, the last phase, z phase. 4, phase number 5, S5 of f dot n ds. So here z equal to 1, this implies ds equal to dx dy, and z equal to 1. So our equation will be, our equation will be what is f dot n, and n equal to, here n equal to k. What is our f? What is our f? F is 4xy of I minus y square j plus zx of k. Then we are taking the dot product with the k. K if we are taking, and ds is dx dy. K dot k is 1. So k dot k is 1. So this all becomes 0. So double integral 0 to 1 zx dx dy, and z is 1. So it will reduce to, if z equal to 1, it is 0 to 1 x dx, 0 to 1 dy. So this will give us, x square by 2, 0 to 1, y 0 to 1. So this is 1 by 2, 1 minus 0, 1 minus 0. So this is half, making equation number 5. Now equation number 6. So integral S6 f dot n ds. F dot n ds is double integral. See here. See here, the same thing. Same values will be here. So here we have to take z equal to 0. Z equal to 0 means, and ds is the same. Dx dy. And n will become minus k. Unit vector opposite to the face. So now if we take here, if you take here, if you take here z equal to 0, 0 into anything is 0. So ds, this is equal to 0, equation number 6. So you have 6 equations. So what is that integral say taken over the surface? Yes, f dot n ds equal to integration taken over the surface 1, surface 2, surface 3, surface 4, surface 5, surface 6. So what is surface 6 we have? What is surface 1? What is the surface 1? We got 2. Surface 2 0 and surface 3, surface 3 minus 1, surface 4 0, surface 5 half and surface 6 0. So now these three values. 2 minus 1 is 1, 1 plus half is 3 by 2. And what we got? Divergent del dot f dv. What is the answer we got from the 1? It is 3 by 2. It is 3 by 2. So both the answer you see. This is 3 by 2. This is also 3 by 2. Integration surface over the n f dot n ds. Both answers are same. So therefore, theorem is verified. So therefore, integral taken over the surface yes, f dot n ds, f dot n ds equal to integration taken over the value v del dot f dv. They are equal. Equal means theorem is verified. Gauss-divergence theorem is verified. That's it. You see here one thing about the diagram I want to show about the, don't get confused about this thing. I think I did not make it clear while explaining. You see when we go this one face, you see this from here to here x equal to 1. Here x equal to 1, here this face opposite to this face x equal to 0 will be there. And if we go for this face, let me change this color. For this face, you see this face and this face, you see opposite faces. This is y equal to 1, y equal to 1 and n equal to j. Here y equal to 1, it will be 0 and n equal to minus k. And another thing is for z. Let me change the color and show you. This is over. This color, let me take this, which is the light color. This over. You know this color, this front color, this front. That means BS PQ Z equal to 1. C. The opposite to it CQ AO, like that, opposite faces. This face x equal to 1, back of the face x equal to 0, and n equal to I, n equal to minus I. For y, n equal to j, and y equal to 1, and y equal to 0, because it is 0 to 1 is there. According to the problem, we have to adjust. So the video is becoming very big. So I want to solve all the types of Gauss-divergence theorem. I'll make separate videos for different problems. Okay. Thanks for watching. Please do subscribe my channel. And you need 1 or 2 times to do this to get the clear picture. Thanks for